Okay. So now I did this slide already. So I basically did this slide here, but I'm just gonna reiterate. I will introduce myself and I did the idea of the talk, which I can did. And here's the other part. First, we have to install DESDEO and see how the main ideas are to how to use it in interactive manner. And then we think about how to use DESDEO to formalize your own multi-optimization problem, since that is actually a very important part of the solving the problem. Have it. And then we have some idea how to add new contents to DESDEO. So I'm a user master student in the multi-optimization group here at the University of Jyväskylä. And well, I've worked on extended DESDEO, either here and there, some on tools, some on emo, DESDEO emo, some on the old web graphical user interface, which is now deprecated, so take it as you want. What this means that deprecating that I worked on it. Anyway, yes, we are familiar with the multi-optimization and interactive methods, both in the scalaration-based and evaluating-based, and some of these preference approximation types are classification. And this talk somewhat assumes familiarity with the basics of Python and Git to understand everything. But as said, the point is not to understand everything right now. You can come back to slides. You just need to get an idea how things work. And we have a plentiful documentation. For example, this paper has very good ideas and explanations about these ideas. So you can look at those things too. And as this is a tutorial, questions are also welcome. But let's get started so we don't run out of time. How to get started? Well, you need the working version of Python 3.9 or newer version, and you can just find the main DESDEO package, circled, and install it with pip. And there you go. You can use all the methods and also existing problems and everything in DESDEO with this. We also have a documentation how to do this. There's a link for it. Okay, so everything works out nice, especially on this slide. So we have working version of DESDEO right now. So now we need to have a multi-optimization problem solver, and then we need to select the interactive method to use to solve it. And of course, we need decision maker preferences, the point of interactive methods. And DESDEO uses this demo problem Python class to represent the multi-optimization problems. And for now, I'll just mention it because in the test problems, we have multiple real-world inspired multi-optimization problems and some benchmark problems. But the main point is that they are represented by this demo problem class. And I'll just show an example how to use one of these, how to use it in the code level so you can see. So you basically can just import these real-world inspired problems, and then you can just call it normally as any Python function. But the test problem builder is useful if you want to use these benchmark problems such as CDD and DESDEO, where you can redefine the number of objective functions and number of decision variables for DTGL problems. So it doesn't have to be the default setting. You can have your own combination. And but basically the idea is just like this. Get the problem ready and to go. And well, how these interactive methods work in DESDEO? The main idea that we have at least these two ideas. These methods start and iterate. Every interactive method in DESDEO has to do this. We need to get started, of course, and all of these things return this at least this reference request object that wish I had something important things. Not gonna get that one. So this one methods always return at least this one. We are not focusing on the other one right now, so that's why it's underlined. And you give your preferences to decision maker, works with the request object and sees things and give the preferences to response, and then the response the request with the new response will be given to iterate, and we keep going. And the request and responses will be going over next. So we need to have some example method so we can start. Let's just have an impulse here. So we make the impulse method and we give problem for it, and we can also in DESDEO to give the specific solver. This is just Kipus differential evaluation solver that is basically the same that it's Kipus. So we are just using it. And then we get started with the method, and we get the reference request, and the reference request has this message that always has information for the decision maker about, okay, what preferences this method wants, and how should you do, how you should provide them. And for example, we see that this has the classification information. You can get how to improve and how to improve until someone and some desired preference level, and so on and so forth. So this, probably with the help of the analyst, the decision maker provides some classification for the object functions, and they are here, for example, to improve the first objective and keep the second objective the same, and the third objective until certain limit that is given here. At the levels, aspiration levels, and also the decision maker wants 3 new solutions we generate. And as said, we set the response to here to this object, and then we take the next iteration. This is the main idea in this. And as said, different methods can use this in a different way. For example, some evolutionary algorithms will spend some generations and then iterate at some points. Some correlation-based methods work in the standard that you give preferences, you generate solutions, you give new preferences every iteration. And as said, DESDEO contains plenty of examples how to use the benchmark problems and different interactive methods. We have example, impulse example here, how to use impulse. Have a inspired revolution problem to solve it interactive REA. Is car side impact design problem. And also we have a video tutorial how to use DESDEO. That's very good tutorial. Yeah. So before we go to the next part, do you have any questions about this? Yeah.
Yeah, just a quick question. So you state the preferences of the objective space. Could it be possible also to state preferences in the decision space?
So in multi-objective optimization and in our group, we work mainly on the objective space. And that's why the idea is that the objectives are important to decision maker, so the decision maker understands the objectives, so he wants to be in the objective space. I guess you could work in a way where you would give them in decision space, but then a decision maker has to switch between decision space and then objective space, and that might be hard to understand. So I don't think actually right now we have any plans to even go providing preference in decision space, but
I would like to add that if there's some particular variable for which you want to provide preferences, then you formulate it as one of the additional objective functions.
Yeah, so that's kind of just how we look.
That can be done, and that has been done, but typically preferences make more sense. Sorry to steal a bit of your time, but the idea is that the objective functions characterize the goodness of the decision to be made. So the preferences, well, in most cases, naturally reflect this characteristics, these perspectives that characterizes the goodness of the decision. So providing preferences to this information is meaningful and justifiable. But as said, if there are some particular variables that need to incorporate preferences, then we can have the variable as an objective function. Of course, then it is very simple linear objective function, but it is not creating any problems. But if you want to provide preferences to all variables, then we don't have.
But perhaps I'm like more referring to the case where you have two solutions that are very close to each other in the equally preferred, let's say. Perhaps you want to see like what does that decision actually look like, and there could be.
That's another thing, if you want to see what the corresponding decision variables are. But if you want to provide preferences, how to change them, then you need different tools. It sounds like sensitivity analysis or something like that.
Okay, yeah, let's keep going. So, well, how would you go about creating a multi-object optimization problem in DESDEO? So we look at the DESDEO problems, problem class, which contains this MO problem class. We briefly talked, and the main point, we have variables, objectives, and constraints, and each of them will be built into the MO problem class to build. Yes. So variable class is to present the decision variables. It takes as arguments the name of the variable and starting value, and then lower and upper bounds. And of course, you need to have the starting value with the bounds, and you should have meaningful decision variable names for the decision maker. And as mentioned, right now there's the current supports only continuous decision variables, but in the minimum viable product, you have mixed integer variables. And we also have this variable builder where you can give the arguments as a lists, which may be more preferable. For example, if you have 20 decision variables, we don't need to do the same thing 20 times. The objectives require the name of the objective functions and this evaluator, which is a Python variable, which basically is a type that can be called in Python, and it takes in the input the decision variables and returns the corresponding objective function values. And this evaluator can be defined as a Python function. It can be maybe some simulator, third-party simulator, whatever that is implementing this Python type that we can call it and give the right input and output. And you can also keep lower and upper bounds for the objective functions and define some of this function to be maximized in default. In DESDEO, we always minimize the objective functions. And we also have two types of scalar objective vector objective, and the only difference is that if your evaluator returns more than one objective function at the time and evaluates more than one of the objective functions at a time, then you use the vector objective, but otherwise just use scalar objective. And we have some simple objective functions, and just define them, and now there are some callable that you can feed in the evaluator argument, and you can build the objective function and use it in DESDEO. And it is just with the extra arguments, you just put them as extra arguments and that's it. So constraints, we have this color constraint class, and so often the constraints are depending on the decision variable values, but it's sometimes possible that objective functions are included. So in the main part is that in DESDEO, you should define the constraint as a way. It returns a positive value if it's met and a negative value if it's not met. So for example, if you have this kind of x1 plus x2 plus x3 should be equal or less than 10, then you need to turn it in this form, 10 minus sum of them is 0 in DESDEO. So in this case, if the sum is greater than 10, it will not be met the constraint, and you can see it that way. And other than that, you just give functions and the name of the constraint and number of variables, number of the functions. Okay, so to put this all together, you can see how to do it here. So I'm just repeating the earlier parts here. You don't need to pay too much attention to that part, but the main part is just you give the variables as arguments and objective as constraints. Everything is a list. And if you, in your problem, you have an ideal point or ideal point, you can give those as well. And, but if you don't have them, you don't need to. And one thing to still mention about the small problem, that we have this evaluate method there, and that evaluates all of the given evaluators from the defined objective functions and constraint functions, and provides the corresponding objective values. So it's very easy to test some test decision variables, for example, when you're working, building it, or in the methods that is using it. So this evaluate method get, for example, the objective values. You just call the resulting object dot objectives, and here is just some random trace data to give this problem we formed earlier. And the values are not meaningful for this talk, but the example is relevant. And the evaluator also has other information, but it's not relevant for here, but you can look from the DESDEO documentation about it. And as we can see, the idea is to have this 2D NumPy arrays, we have one objective vector per row, but it's easy to think about and see. Okay. Lastly, I'll mention about data problem. So Giovanni talked about how problems can be data-based, and data problem is a class that's built on top of MO problem class. And what we need to know about it right now, that is, if you have, for example, some data, you have some CSV file for example, you just need to put it as a pandas data frame and return it to the, give it to the data problem as an argument. And then you need to also provide the variable names and objective names and data frame to indicate which objective to be maximized or which objective is minimized. I also have the further examples about this in the documentation. One other thing you need to know is that, well, if you need to have some surrogates or something, data problem has the train method that you need to implement and have or run with your surrogate model or whatever you have. Yeah, so any questions about that part before I go to this last part?
Two variables, for example,
Yes.
and these two variables are defined as the features in the data set.
So yes, they are just they need to be included in the data set. So in my DESDEO data fake, whatever, we have these features of A and B, and then we have these columns of F and to correspond to them.
I mean that, for example,
The first row in the CSV file contains A, B, F1 and F1 as strings, and then the rest of the rows are the values corresponding.
So it's just straightforward. Okay. Yeah, so how would you go about adding new contents to DESDEO? So if you're not familiar with it, there's plenty of tutorials, but I'll just go over a little bit about the workflow of doing these things. So as mentioned, we have these packages like DESDEO problem or DESDEO MCDM, if you want to contribute and work with DESDEO, you will want to fork this package, let's say DESDEO problem, you fork it, GitHub, and when you have your own form, you can then do things there that are not affecting the main repository. So you can really play around it and work on it. So of course, you need to clone your local machine, and then you can work on it in your machine. Maybe you want to make a new branch to have separated pages, and then you do some coding and commit the code and push, and then you make the pull request. So this kind of is very general workflow about Git, and it works very well using DESDEO2. And we have plenty of tutorials about contributing to DESDEO. We have a video tutorial here. This is just some random Git tutorial that you can use from free code camp, and we have contributed guides to DESDEO. But when you install DESDEO and you want to develop it, or you want to work it in more a power user, you need to use Poetry, which is a tool for dependency management and packaging in Python. And I went over the parts, but I just rephrase it again, that you forget and you clone the repository for DESDEO problem for like that, and change the directory to the repository, and then you can make a new branch and change there. And if you want to use specific version of Python, for example, you have different Python versions and you want to use, say, 3.9, you can do it that way using Poetry. And then you init Poetry and you install using Poetry all the request packages. And that's how it's installed. And you can start working on your code. And now my own here, my problem is written. Just contains this definition for MO problem, and the main point to understand this, you of course need to return it, so you can access it later when it's implemented. DESDEO. So then you work other parts of committing, pushing, make the pull request, and somebody in the DESDEO team looks at your pull request. Maybe there's some discussion about how to do things. They are not quite like we like it, or maybe there's you have questions and we help it. But anyway, after it's been accepted, everyone can use your test program or real-world inspired program. It's very nice and helpful to all. Yeah, some additional information about extending DESDEO or contributing DESDEO. So we have a lot of things already, so you really should always try to use as much as you can of the existing code. We have plenty of functions that you can probably use. And for example, fast nominal sorting is included in DESDEO rules. And this helps you to keep the modularity of DESDEO in mind. So your work is also modular and easy to use by others. And I have a caps lock on testing because that's something very important. You should test your code and make unit tests and make sure it works, and the common issues are taken care of. Maybe you put too short list for a method and it breaks, you should have test for that. And another important point is the documentation. It's of course for you and for other people, but I like to think it's also for other versions of you in the future who is looking at it, and you might not remember everything you thought about in next week or the next month or next year or later. This I don't remember anything after 2 weeks, so I should not. And again, as it's open source, you also welcome smaller contributions or small typing errors, finding some issues that you have noticed, just report them in the GitHub, and then it's very helpful because when you're using it, you're testing it, and if you notice some issues, may have not noticed it, so it helps to report them. And yes, if you use DESDEO in academic work, it would be nice to cite the DESDEO paper. There's another link for it. It's well advertised, and again, we have the contributing guidelines, which has all the details about like clean flags, something like that. Yeah, so in summary, discuss how to use these benchmark problems and we already implemented multi-optimization problems in DESDEO and how to get started on building of your own multi-optimization problem using the classes included in DESDEO problem and get some basic understanding of how the interactive methods are made work in DESDEO, help you later and maybe think about how would you do your own method if you're interested in that kind of stuff. And of course, how to understand how to use them. And we have documentation that's gives plenty of examples. I hope with this tutorial you're more ready to look at the methods and see how to get started. And yes, also we saw some example workflow of how to work and maybe become a tester contributor yourself one day. Yeah, any questions about